Hi all, in this video I'd like to introduce you to Recce. Recce is short for reconnaissance, and with Recce we've created a data reconnaissance tool that will help you validate your data modeling changes by creating validation checks to use in pull request comments to speed up review. So Recce will enable you to create the all signal, no noise pull request comment. And what's special about Recce is that it makes cross-environment diffing so easy. So take two environments, commonly production and development, and perform one query or validation across both environments and compare the results in a browser. So I say validations because it's not only query diff, which is powerful in itself, but also schema diff, row count checks, on-demand data profiling, value diff, and of course lineage DAG diff. So we feel the best way to validate modeling changes on your data project is to compare your changes with historical data. So I mentioned two things which are at the core concept of Recce. The first is speeding up QA for PR review, because validating data modeling changes isn't easy and QA takes time. And once a back and forth starts between reviewer and submitter, PRs can take days or weeks to merge. Using Recce to create those cross-environment validations means no more writing complex queries or configuring tools on a per project basis. Recce becomes your one interface for validating the proof of correctness of your work. And the second is you can do on-demand validations. So we like automation, and some aspects of Recce will enable automations, but the essence of the all signal no noise PR comment starts with curated checks performed with the knowledge of the context behind the change that you're making. So I have a quick demo for you that will show the features of Recce. It's a simple example, which is a modification of DBT's JavaShop project. So I'll take you through the code that represents the modeling change, how to validate that change using Recce, and then adding those validations to a pull request comment for review. So the modeling change that we've made updates the way that customer lifetime value is calculated inside the JavaShop project to only include orders which are completed. So previously this would include orders with any status such as returned, so it wasn't an accurate representation of customer value. So after making this change, how do we validate it? So with any model code change, you have an intention and an expectation, and the purpose of validation is to verify that the change is implemented and the expectations are met. So let's take a look at Recce. So the main interface to Recce is the Lineage DAG Diff. So models here are color-coded, which indicate which have been added, removed, or modified. And you can use this interface to determine the zone of impact of your changes. So the change for this PR was the customer's model, and we can see that model is highlighted in orange here. From the lineage view, you can perform holistic types of checks. So clicking on the model here, we can see the schema diff pops up, and there are no changes here, which is good. We didn't touch the schema, so we wouldn't want to see anything here, but new columns would be shown here, as would deleted and renamed columns. So from here, I can quickly check the row count for this model. And again, we didn't lose any data. If there was a row count change, that would be indicated by an arrow, or you would see the number of previous rows and current rows listed here. So let's take a look at some checks that we would expect to see some impact. So down here we've got value diff, and value diff runs a check on matches for each column and gives us a percentage match. So let me select the primary key. So for the customer lifetime value, we can see there is a 73% match compared to production data. So we know that our change has had some impact on the data. So in other words, there's a 27% difference in this column. So as I'm checking these things, I can add them to the Recce checklist so I can review them later. So let's add value diff as a check and put a note in the description that 27% of values have changed for CLV. From here, we know that there's been impact, so we want to find out what type of impact has happened to those 27% of rows. Let's go back to the lineage here. We'll click on the customers model and run a profile diff. So a profile diff shows a lot of statistics about the model, and if we scroll over here, we can see that the average value of CLV has dropped. And that's a good sign, because we've made a change to that model. We've removed some of the orders from that calculation. And so we would expect to see an overall drop in values of this column. So I'll add the profile diff to the checklist. The The next step would be a spot check on the data to see the actual values, and we can do that with a query diff. So again, selecting the customers model, going down to the query, and with query diff you can run any ad hoc query and it will diff the results between your two environments. So for this change, I'd want to spot check a few rows and see how they were impacted. So I've got a query that I've made earlier. I'll paste that in. So if I run that diff, I can select the customer ID as the primary key, and then we can see which rows have changed data. And if I check the changed only box, we can show only those that have changed. So our findings are that for each row there has been a decrease in the customer lifetime value, which is exactly what we want to see. So I can add this change to the checklist and add a note about what I found, and I could add something in here if I had more time. So an important note is that when you run a query diff, you can use any macros that are installed in your DBT project. So you can build queries as simple or as complex as you like. The benefit of having the Lineage DAG as the main interface is that we can quickly see downstream models as well and perform the same kind of checks on those models that we just performed on the customers model. So customer segments, the customer segments model is how customers are organized based on their value, their customer lifetime value. So we know there'll be some impact here. We can see that customer lifetime value is used here. So if I do a quick query diff on this model, you can see that for a subset of customers, the lifetime value has reduced, as we already know, and then that has in turn reduced the value segment for a subset of those users. So some of them have turned from high level to low level. They don't have any orders, and the same for some of these customers here. So this impact in downstream data may have an impact on stakeholders and how they're using the data. So for this particular change, we might say we want to notify those stakeholders of this upcoming change so they can be ready to accept that. So back over to the checklist here. So the whole point here is about building the all signal no noise checklist. So from the list of checks here, we can now select which ones would best demonstrate that the modeling change that we've made was implemented correctly and add those to the pull request comment. So I already have a pull request comment open here with my template ready, and I can start adding validations to it. So if I go back over here, I can look at the value diff, click on the three dots here, copy the markdown, which will copy the type of check I ran and my description. If I paste that into my comment here, and I come back over to Recce, and then click on the copy to clipboard for the screenshot here, and that will copy the table that you can see, and then I can paste that directly into the pull request template here. So not forgetting Lineage DAG Diff, which is an essential part of any DBT PR comment. So if I go back over to the Lineage here, I can click one button, select that to the clipboard, paste that into the Lineage DAG section here. And so taking a look at the PR preview here, we can see that the comment is now taking shape. We've got the Lineage DAG, and we've started to add validations for our models. Now if I scroll up, you can see what a completed comment would look like. So this one has all of the relevant screenshots here, the validations of models and impact considerations, which are the downstream impacts. So you can really fine tune what you add depending on the context of your change. And that's how you can curate those checks and create the all signal no noise PR comment. So on the one hand, Recce will help you to validate your changes, and then on the other, it helps the reviewer to understand that impact and speed up time to merge on your DBT project pull requests. So what's coming for the future? So what I've demonstrated here is the OSS version of Recce. It's available now to use. It's open source. It's on GitHub. I'll post a link down below. For future versions, and in particular for Recce Cloud, we have new features coming, such as automated checks. So for those instances when you know a specific check needs to be run against the model for every change, then you will be able to automate that. And then Recce Cloud would also enable the whole team to be able to open Recce, view the results, perform queries, and run checks themselves. Our ultimate aim here is to turn the pull request comment into a true living document and make the task and interface of validating data model changes as fluid and accessible as possible. So I hope you try out Recce, and we're anxious to hear what your thoughts and feedback are. So thanks for watching, and let me know if you have any comments.